All right, IBAI SL2, we finally reached the end of our probability unit, which was, the second part was mainly focused on probability distributions. So, know how to fill out a problem that has like a probability distribution table. So this is just a little example of one here, where this could really be anything. It could be like, the number of lamps in a store, the probability of rolling something in a dice game, whatever. All of these probabilities in the table need to add up to 1. So if we know how to find expected values. Expected values are a lot like just an average from like a frequency table, where you're taking the sum of all the x's times their respected probabilities and then adding them together. There was a little bit in there about when an expected value is 0, that's like a fair game, like at a carnival or something. Like, if the expected payout is $2 and you're paying $2, then it's fair. Yeah, that's when the probability or the expected value for the whole entire thing is 0. It's not positive or negative. Negative would mean you were losing money. Positive would mean you were making money on average. Binomial distributions came up. Those were a lot of like marble vase problems, or like just anytime you have a bunch of trials where like something can happen a lot of different ways. Like, how can you have 2 boys in a group of 10 kids or something like that, because there's so many different ways it can go. You can figure out, how many different ways you can have 2 boys in a group of 10 people using NCR. Remember that this came from Pascal's triangle, but I won't necessarily ask you to like recreate or find parts of the triangle, but it did come from there. We did a lot of using binom PDF in our calculator. Remember, that's like usually the wording is exactly a certain number, like the probability of it getting exactly 3 heads out of 10 tosses. Excuse me. And then we use binom CDF, which, remember, binom CDF always goes from left to right, or starts smallest to biggest, and that's usually when the language has something about less than or greater than, or less than or equal to, or greater than or equal to. Some other things that you see with that are like at least or at most, something like that. With a binomial distribution, if you want to find the expected value, you just take n and multiply it with p. If you want to find the spread of the data, which is the variance, you take np and multiply it by 1 minus p. The last thing we did were those normal distributions. Remember, normal distributions are your classic bell curve. They have a mean right in the middle, and then they have standard deviations that go up and down from there. Know how to find certain percents under the curve, but I think we mostly did that with normal CDF on your calculator. Remember, that's a lower limit, an upper limit, a mean, and a standard deviation. Sometimes if it's like, what's the probability of it being less than 10 or something like that, then your lower limit needs to be like negative infinity, or your upper limit might need to be positive infinity. The way you trick the calculator into infinity is 1e to the 99. Also, there might be some question where you have to work backwards, where you're trying to find a certain, or you're given an area under the curve and you're trying to find the score cutoff. That's where you need to use inv-norm, which goes percent, mean, and then standard deviation. And remember, the percent is from the left. Okay, you guys, ask me questions in class. Good luck.